All right, in this last lesson for matrices, we're actually going to look at how you can use matrices to solve systems of equations. Um, and you've already learned to solve systems of equations using elimination and substitution, and even graphing in your earlier algebra days. But that doesn't work as well when your systems are much bigger. If you have more equations or more variables, it gets really complicated. And with matrices, if you have a technology that'll let you solve the matrices, it actually works really quick and is much shorter. So the first idea is we need to take our system of equations and we need to turn into what's called an augmented matrix. Now, this line that's here, you don't have to draw in there. You wouldn't lose points if it's not. But that line is meant to represent the equal sign. Sometimes people draw it as a dotted line. And it's really more so to help you keep track of where you are. But the idea with an augmented matrix is that we are going to just pull off the coefficients of each of these numbers. With the one catch being, if there is no number written in front of like this y, we need to remember, of course, that that's technically a 1 in front of each of these, and that would be the coefficient we would use. So if I was going to write the augmented matrix for this system, I would have a 3 for the 3x, a 1 for the 1y, a 2 for the 2z. Again, that extra line inside there is to remind you where the equals sign is, and then it equals 31. In the second row, we would have a 1, and a 2, and then a 19. And in the bottom row, we'd have a 1, a 3, and a 2, and a 25. So that's how we get it into a matrix that we can do some things with. The one other one I wanted to show you is if you have something like this, anywhere that you are completely missing terms, we need to fill in zeros. So this is really 0x plus y plus 3z. And that bottom row is really 0x plus 0y plus z. Even though we're not technically writing those out. The reason it matters, and normally we wouldn't write them and normally it wouldn't matter, the reason we need to write them out, or we need to remember that, is in an augmented matrix, you can't just have spaces. So that top row is 1, 2, negative 5 with the 19. The second row of this matrix has to have a 0 first, then a 1, then a 3, and then our 9. And then the bottom row would be 0, 0. We have the 1 for the z, and then our 4. So that's kind of step one, going from equations written on paper to getting into a matrix. So now that we have a matrix, how do we solve a system with it? So we're going to use the calculator here to do this. To enter this into our calculator, first we need to get to the matrix menu. To do that, we're going to press second, and then we're actually pressing the x to the negative 1 button, which is right underneath the math button. It says matrix right above it. Then we need, right now, this is just if you want to choose one of the matrices. We don't even have anything in there yet. So we are going to go to edit and hit enter. Next, we need to enter the size of our matrix. Now, it's possible that you have something else in here besides 1 by 1 and 0. If a program used this or if you used this before. But we want to make, if we're going to enter this matrix in, it has 3 rows and 4 columns. So type in the number, hit enter, type in the number, hit enter, and then enter our values in. So we're going to type in a 3, 1, 2, so then once we have our values in there and our matrix is set to match theirs, we're ready to move on. So next we are going to hit second mode. That'll get us out of the matrix and out to a blank screen. And then we're going to go back into that matrix menu, second, and the matrix button, but we're going to go over to math. And there is a specific calculation we can use here that will solve this for us. We want to go down to, it should be B on most of your calculators. There are a few whose operating system is slightly different, but we want the one that is RREF. And you need to be careful because there is one that's just REF, which gives you a slightly different version that we don't want. We want RREF, and then press enter. If you try to hit enter now, you'll get an error. Because what the calculator needs to know is what matrix should it do this RREF RREF stands for Reduced Row Echelon Form. If you ever take a class that goes more in depth in matrices, they'll talk about what that means and how that works, but for now, this is good enough for us. We need to put in the name of this matrix. So we're going to go to second, the matrix menu, and this time we actually do want to just hit enter on this first screen so that it pulls that matrix A for us. And now if you hit enter, this is what the calculator spits out. And then the question is, well, what the heck does this mean? Well, this matrix came from this original system of equations. And when we made it into a matrix, we got rid of the letters. But that first column really stands for all of the x variables. And that second column really stands for all of the y variables. And the third column stands for all of the z variables. So after we've done the RREF, what the calculator is really giving you is what value x has, what value y has, and what value z has, and you really can read it off again like an equation. So this first line would really be 1x plus 0y plus 0z equals 6. Well, if that's the case, 0y and 0z don't really matter, so it's really telling us that 1x equals 6 or that x equals 6. So that's what that first row means. In the second row, similar idea, but it would be 0x plus 1y plus 0z equals 3. But again, whoops, that should be a z. But we're not going to actually write out the 0z or the 0x, and we really don't even normally write the 1. So this second row is really telling you that y equals 3. And then similarly in the bottom row, 0x plus 0y plus 1z equals 5 really means that z equals 5. Let's try one more then. Here's our original system of equations. So we're going to turn that into an augmented matrix first. And again, if you want, you can draw the line in there. I think that does help some people visually, but you don't have to have it. But then we need to enter those values into the matrix. So go to second, hit the matrix button. We're going to edit this matrix. It's still a 3x4, and go ahead and enter your values. Okay, you might want to pause while you type those in so you can follow along. Okay, once I'm done typing them in, then I want to do second mode so that I'm not in that matrix window anymore. But I've got to choose second, then matrix, arrow over to math in that middle column, and then I want to scroll down to RREF. And RREF, hit enter, and now I want to do RREF for matrix A. So just hit second matrix again, and just choose matrix A. After I hit enter, it sends out my solution. So here is that matrix now. And again, x plus 0 equals -1, 0 plus y plus 0 equals 2, z equals -3, and now that's my solution. Now again, compare this. So this is a much more compact, certainly, and we had to use the calculator, but much more compact. Just to give you an idea, here is the work that would go with solving this same question by hand, where you actually take, and the way it works is you take 3 equations, pick 2 at a time, and solve for different letters. Then you take those answers and solve again, and then you eventually go back and plug in your values. So this is a place where matrices are a huge advantage for how quickly they can do these problems. Okay, here's one more to practice. Why don't you do this one first on your own, and then you can follow along as I type through things quick and double check your answer. Probably the biggest thing we need to be careful of here is that you put in a 0 in that middle spot. Otherwise, it should be relatively straightforward to type this in. And then once it's in there, we want to quit out of that matrix, but we'll go to our math part of the matrix menu. Another way to get to that quicker is you can just do alpha B, and it automatically chooses it for you. You don't have to scroll down then. If you're somebody who likes shortcuts, if you don't have to remember one more thing for buttons, that's fine too. You need to choose matrix A, and then I solve. So here's my augmented matrix. Here's what it changed into, which means that x is 3, y is 4, and z is 5. So as far as the process, that's it. The question is, what else maybe could happen here? And there are some other things that could happen. You don't necessarily need to type along this time. You can just watch this and maybe take a note of what takes place. Here's my augmented matrix. And for this particular system, when you do your RREF, this happens, which looks really similar, except instead of 1, then 1, then 1, and zeros in these other spots, this bottom row is a little bit different. And if we think about what this really means, it means that in the bottom row, we have 0x plus 0y plus 0z equals 1. Well, that's not possible. So if the bottom row is impossible, and a lot of times it'll be a 1, but it could be some other number over here, that means that this system of equations has no solution, and that would be your final answer. In this last problem, our solution is x equals 3, y equals 4, z equals 5. Here, you would just show this, and then you would say no solution. There's one last possibility we haven't addressed yet. Again, you don't have to type this one in. You can just follow along. But if I put the coefficients in for that matrix, and I reduce it, this time I end up with this. And again, we see something weird. Instead of all zeros with those ones on the diagonal, I don't see that one down here. The difference between this one and last one is that bottom row. Here, we had 0 plus 0 plus 0 equals 1, which is impossible. Here, we end up with 0x plus 0y plus 0z equals 0, and that's possible all of the time. In fact, any combination of solutions for x, y, and z would still work. Sorry, that's not quite right. Not any combination, but there are infinitely many solutions. There's an infinite number of solutions. Not literally anything will work, because those top two, we would have to be careful what values we pick. But if you end up with a bottom row that's all zeros, our system overall has infinitely many solutions, and that would be your final answer.